Hi folks, we're going to be doing some more math. Today we're going to be working from section 2.4 and we're just going to give a general overview for this section. So this section is basically just about learning about different ways to count possible combinations or outcomes of a particular question. There's a lot of ways that we can do this, and it frequently comes down to whether or not the options for our arrangements are being replaced or not, and then whether or not the order matters. So for example, if you're choosing a PIN number, you have 4 options for your PIN number, and for every single slot of those 4 options, you can choose any number from 0 through 9, and you can repeat whatever number you want however many times, and it doesn't matter, but the order does matter. So if you were trying to choose a PIN number, you know there would be 10 options for any digit, because 0 through 9 is 10 different options. So then that would just be 10 times 10 times 10 times 10. So there's 10 different options for each slot, and there's 4 slots for a PIN number. So that would give us 10,000 possible PIN combinations. But what if you were selecting something that couldn't be replaced? For example, if you were trying to figure out all of the different possible outcomes for winning a prize from your middle school classroom. Perhaps you had 30 people in your class and there was a first, second, and third prize and everyone got something different. You would not be able to just use this same formula to figure out all the possible combinations because people can't be picked more than once. So the objectives for this section are going to help us figure out different formulas that will help us essentially count the number of possibilities for different arrangements of outcomes. So our objectives for this video are to develop and apply the permutation formula, develop and apply the combination formula, and determine the number of distinguishable permutations. So for permutations are used whenever there is more than one item being selected without replacement from a category, and the order of selection is important. So this is the permutation formula. In this formula, this is essentially what we're solving for. In this formula, R is the number of items being selected, and N is the total amount of options that you have to choose from. So for example, if we had to select 3 out of 112 people without replacement, and the order in which they are selected is important, we would solve that using this permutation formula, and it would look like this. So the way that I've set this up means that we know there are 112 people that we're choosing from, and we have to select 3 of them. So if we plugged all of this information into our formula, we would get 112 factorial divided by 112 minus 3 factorial. And if we put that into our calculator, we would see all of the different ways these 3 prizes could be awarded. So it ends up being 112 factorial divided by 109 factorial. And if you plug that into your calculator, you should get 1,367,520 different combinations of winners for this question. So that's how you would plug this information into this formula and solve any question that looks like that. Next, we're going to talk about combinations. Combinations are used when one or more items are being selected without replacement from a category and the order of selection is not important. So this is the combination formula, and in this formula, the number of distinct combinations of R items selected without replacement from a pool of N items is denoted by this, and this is the formula that you would use to solve any combination problem. So let's try one out. Example, a DVD club sends you a brochure that offers any 5 DVDs from a group of 50 popular releases. How many different selections can you make? So because the order is not important, we're going to find the number of combinations when 5 items are selected from a pool of 50 by plugging it into that formula, which should look like this. So we've simplified that a little bit, and if you plug this into your calculator, you should get 2,118,760 different selections that you could make of these DVDs. And that's how you solve any combination problem. This next section is about distinguishable permutations of identical items. So basically it's pretty similar to the last couple of problems, but if two of the items that you're trying to choose from look identical, it's going to be hard to try to figure out which one is in use. So this is what you would use if you have a question that uses identical items. So the number of distinguishable permutations or arrangements of n items in which x items are identical, y items are identical, z items are identical, and so on is n factorial over x factorial times y factorial times z factorial, and so on. That is, to find the number of distinguishable permutations, you have to divide the total factorial by the factorial of each repeated item. So let's try that out. For example, if we're asked to find the number of distinguishable permutations of the letters in the word Mississippi, we would have to do this. First, we would have to identify the repeating letters. So overall, our n, or the total number of letters, is 11. If you notice, I is repeated 4 times. Let's make that Z. S is also repeated 4 times, and we can make that Y. And P is repeated twice. We can make that X. So if we plug that into our formula that we got earlier up here, that would look like 11 factorial over 2 factorial times 4 factorial times 4 factorial, which, if you plug that into your calculator, should equal 34,650. So this is the number of distinguishable permutations of the letters in the word Mississippi. So that's how you find the number of distinguishable permutations when you're using identical items. So this is a flowchart that you can use when you're faced with any question in this section. This flowchart will help you figure out what formula you want to use or what counting technique you want to use to solve the problem that you're faced with. So when you have a new question, you just start at the top of this flowchart, ask what is being selected to figure out where your important information is and whether or not it can be repeated. And then you ask, can the selected items be repeated? If the answer is yes, use the fundamental principle of counting, which you learned about last section. If not, then you have to ask if there's more than one category. If the answer is no, ask, does the order of selection matter? If the answer is no, you use the combination formula that we just learned about. If the answer is yes, you use the permutation formula you just learned about. If there is more than one category, use the fundamental principle of counting with 1 box per category. For each box, ask, am I selecting only one item per category? If the answer is yes, simply enter the number of choices for that category and then continue on to the next category. If there is more than one item per category, you should ask whether or not the order of selection matters. If the answer is no, again, use the combination formula that we just learned about. And if the answer is yes, use the permutation formula that we just learned about. So hopefully this flowchart will allow you to solve any of the questions that you may find in this section. And hopefully this video was helpful and helped you figure out when to use what counting technique and what formula. Thank you so much. Have a great rest of your day. Bye.